All right, let's get started. So I'll start by introducing myself to you. My name is Anna Whites. I'm an engineer with the Southeast Onsite Energy Technical Assistance Partnership Team, and we're based at the North Carolina Clean Energy Technology Center at NC State University. This is the third session in our webinar series of deploying onsite energy called Deployment Best Practices. The first session that we talked about onsite energy examples and their benefits, and this last session we discussed the Southeast policy landscape and explained some of the incentives and funding opportunities available to pursue onsite energy. Today we will be hearing from guests about their onsite energy projects and best practices. So I'll just begin by going over a couple housekeeping items with you. All participants are going to be in listen-only mode, so you won't be able to come off mute or see yourself on the screen. And you can enter any questions you have into the Zoom's Q&A feature, and we'll have time to answer your questions following the presentation. We are recording this webinar, and it will be uploaded to our center's YouTube page, and I can put that in the chat right now. And our past two webinars are already on that if you missed it and want to go back and see those. Also, when you registered, you were given the option to sign up for continuing education credits. If you did so, I will cross-reference your complete attendance today with your registration and send you those appropriate certificates after today. And these are all the housekeeping items, and I'll keep my eye on the Q&A to see if you have technical issues that I could fix in the moment. Otherwise, we'll have time to go over your questions after the presentation. And you can see if any of our hosts or panelists put something in the chat, but you yourself won't be able to use the chat, but just the Q&A section. So moving on to our content for today, we have two guest speakers today. Our first speaker will be Adiel Burgos, who is the Puerto Rico branch manager for 2G Energy. 2G provides a wide range of CHP cogeneration systems, including natural gas, biogas, landfill gas, syngas, and hydrogen in the 50 to 2,500 kilowatt power range. 2G is both an engine manufacturer and a complete CHP system packager of both their own engines as well as a select few engine partners. The U.S. headquarters are in St. Augustine, Florida, with regional offices in Puerto Rico and California. So we're excited to have you representing the Puerto Rico office today, Adiel, and we have several attendees from Puerto Rico today, so we're happy to have you here. Our second guest speaker today will be Will Rice, who is a project manager at Charlotte Water in Charlotte, North Carolina. Charlotte Water is the largest public water and wastewater utility in the Carolinas. They have added a CHP system to their McAlpine wastewater treatment plant that captures and converts methane gas, which is a byproduct of wastewater treatment, into fuel for electricity production and useful heat. So we're excited to hear about this project from you today. Well, again, thank you for being here. And we will also hear from Isaac Panzarella, who is the director of the Southeast Onsite Energy TAP. Right. I'm going to share my screen now. And change this. Okay, display settings. There we go. All right. So for our agenda today, we're going to first have an overview of the onsite energy TAPs again, hear about onsite energy projects from our panelists, and including me, I'm going to speak on NC State's project today. And then we'll move into a moderated discussion with our panelists on onsite energy project deployment. And after the moderated discussion, we'll have time to answer your questions. And again, you can put those in the Q&A section. So we will finish then the presentation by talking about how to work with your local taps. So now I will hand it over to Isaac to introduce the taps.
Hello, Anna, and good afternoon, everyone in the Southeast region and, of course, across the United States, wherever you may be. I'm Isaac Panzarella, Director of the Southeast Onsite Energy Technical Assistance Partnership for DOE. Really appreciate you all having taking the time to be with us here. Do we have the presentation screen on, Anna? For some reason, I'm not seeing the shared screen.
Yeah, I'm sharing. Let me try again.
Okay. So I'm going to just kick us off by talking a little bit about the on-site energy taps. That looks good, Anna.
Okay, thanks.
We're one of 10 regional on-site energy taps that are set up by DOE to provide technical assistance to energy end users and to work with stakeholders around the idea of deploying on-site energy for cost savings, emissions reduction, and resilience benefits. One of the primary services we provide is as technical assistance to specific sites where we can perform analysis of on-site energy for you. We also work a lot to conduct end user engagement, and that's what we're doing here today. And we're really happy to have both Adiel and Will to present with us today. Here, connecting peers among end users is really important to us. This way we can learn from each other. And then the final thing we do is support stakeholder engagement. We really want to work with utilities, utility regulators, and policymakers across our region to promote on-site energy benefits and help them understand how their communities can benefit from on-site energy. Next, please. So the on-site energy program is a bigger program at DOE. The TAPs are part of this program. The on-site program conducts different projects, including research into on-site energy. And here's a list of on-site energy technologies that we work with. We're very broad, and we're here to really help you determine which are specific appropriate technologies for your facility. The next slide shows the national map and all of the on-site energy tap contacts for you, as well as the DOE program contacts. We work quite a bit with other regions because we all share different opportunities and experience into developing on-site energy projects. The next slide shows specifically the Southeast region. Our team here is myself, Art Sandberg, the Assistant Director, Dr. Pedro Quintero, who is our lead for Puerto Rico engagement and technical assistance. He's at the University of Puerto Rico, Mayagüez. And then we have Anna. Anna, thank you for the great job you've done in producing this webinar series, and an engineer on staff, also Steve Lysenko. So with that, I will turn it over to Adiel to talk about 2G Energy's work across Puerto Rico and the Caribbean.
Thank you, Isaac. So let me 1 second. I do have a presentation. Just need the request to get approved, Anna, real quick.
Gotcha.
Yep. Perfect. Got it. Okay. All right.
Looks good.
Thank you. So, got the title there of the presentation, Power in Progress, a Resilient Caribbean Energy Solution. Briefly, just some information is for myself. Adiel Morales, as Anna introduced, the Morales Burgos from Puerto Rico branch manager, and pretty much involved with everything 2G in the Caribbean. Goes from business development, engineering and technical aspects of it, and the operation that we have down here and we'll go into a little bit more of a start with what is 2G, who is 2G, and where is 2G, and then go into more specifics on the Caribbean presence on some of our projects and talk a little bit about those. So as far as who is 2G, briefly, it's just gonna skip through some of this, but public company based in Germany. We do have subsidiaries all over the world. I think we're close to, this is the over 9,000. We're close to go over 10,000 installations worldwide, and can go from everywhere, like Japan, Europe, Canada, US, South America. We got installations all over the world, which is fun. Obviously, our focus here will be for the Caribbean and the US. And as Anna mentioned, we do have our own, we manufacture an own engine from 50 kilowatt up to 1 megawatt. After 1 megawatt, we do have partners that we containerize our solution, and we go up to the latest update is the 4.5 megawatts. So getting up there. I like showing this. It's not fully appreciated in this slide, but Heek in Germany is a small town, and 2G pretty much is the town. This started with just one building, and I feel like every year or two, like they just keep adding additional buildings from the industrial side, and which just correlates for the need of this technology. And now we incorporated heat pumps into our energy solutions, which are being driven and installed quite a lot in the European market, but coming into the North American market as well. So I'll just skip over this. Just wanted to have a visual in there. So this is more bringing it down to this area, North America. Like Anna mentioned, we do have offices, central offices in St. Augustine. We do have another one in Fergus, Ontario. And for the last 3 years, I think we have an office down here, a presence in Puerto Rico. We've been in both about 5 years, but ever growing team down here. And we'll go into the why and how of that. This is just some of our partners and locations where we have a presence. You can appreciate this. Some even we do have an installation in Jamaica, and we do work with some partners down there as well. What do we look for? Where it makes sense to provide an on-site energy solution. And this is just some of the applications. Don't want to spend too much time on this, but pretty much where it makes sense to have an on-site energy, and if it's obviously our focus is cogeneration to keep our efficiencies up. So anything that has a byproduct that we can utilize as fuel, or if we can use our byproduct, which is thermal, to improve the efficiencies of the installation, that's where our projects make the most sense, and this is why. Pretty sure like I'm not gonna have to sling a lot of what combined heat and power, but that's our focus. We produce electricity, use the excess energy, and take as much thermal energy to other processes, be it low, mid, or high heat water, steam, and also chill water with absorption chillers. I mean, our efficiencies are in the range of like electrically around 39 to 40%. 42, and then obviously with the thermal incorporation, then we can go up to 96% efficiency on our systems. And a focus we have right now, it's the hydrogen alternatives. We have over 30 installations already worldwide for hydrogen. We go up to 750 kilowatts. That's a 2G product. So you work directly with our manufacturers on this. And I like this one point which says retrofits get available. For that natural gas installation for one of our products, we went over the exercise, and we were expecting like about 2 weeks to 1 month of downtime to do the swap over. It took less than a week, which was a very happy surprise. And now we refining that process. So I like to have that slogan of install a CHP now, run a water fuel, and we can run with hydrogen tomorrow. And this is just, again, I'm trying to skip over the company stuff. Briefly, just wanted to give us some background as to where it all comes from. But yeah, this is the portfolio range of power and where we are with hydrogen right now. Additionally, from this, we not only provide the products and help the customer on uh, the process of the project integration with our project managers here in the North America side. We also do provide the operational aspects of it, the service. We do have different range. We have a simple, just the preventive maintenance for our equipment, or we can also provide preventive and cover the corrective. We kind of do even the operations and asset management. And where we do the asset management, we can even insure our product with our own in internal insurance due to, I mean, it says average uptime. Like when we pretty much handle anything from platinum over, we have an average uptime of 96%, meaning out of the 108,760 hours of the year, 96% of those we're up and running. Just some visual of what it looks like inside of one or enclosure solutions. There's incredible variety of how this can look. We really can custom tailor solutions based on the customer needs. And we'll go over some of those in a little bit. One of the I'll say nice things of working with having a very standard solutions within a wide range is we simplify the design considerations with our customers. Meaning, you just need to worry about gas flow and pressure, interconnection for the electrical communication is the Modbus. It's going to be through Cat5, thermal considerations. If we have steam, what level of feed water to blow down, and the steam pressure going to the system, and the emissions. And we do help our customer guide them through what they need on their end to make sure that the interfaces are as smooth as possible for the installation. And just some cogeneration. So this is, like, as I mentioned, steam absorption chillers. This is some of the aspects, and we supply them, install them, and commission them as well. So it can be a one-stop solution for the whole cogeneration plant. Now into the Caribbean. So one of our focus down here, it's been that helping in that transition for more on-site energy, and obviously Puerto Rico, like if there's some engineers from Puerto Rico here, or students, or whoever's paying here, we recently, about 2 months ago, had the study, the PR100 study, come out, where it just said that Puerto Rico is completely able to run 100% on renewable. Now there's also the aspect of just because we can, does it make sense? Now there's more renewable coming into the grid. The grid's not modernized enough to handle all the renewables coming in. So there's still a need for on-site generation and traditional generation, let's call it, to be able to help that transition take place to the point where it makes sense. Like and right now, I mean, I think the latest was 2022 where I checked this for the energy distribution, but we're still about 6% on renewable, growing, ever growing, but we're still getting to that point. And the reason why, and this is something that in the States it's not fully appreciated. There's the energy cost, and you can see it on this slide. This is at average across the U.S. In some places it's incredibly cheap energy. On the islands it's not. Like, this is for 2023. I'm waiting to update this table to 2024. It's higher. I can tell you because I pay my electric bills out here, and it's already higher than this. And in the industry, it's felt across the industry as well. And then this, obviously, between unreliable power and cost, it makes a lot of sense to have on-site generation to make sure you cover your bases with the resiliency aspect of it, and obviously with this you can go with the cost effectiveness of it as well. And this is in Puerto Rico and Jamaica. higher that's in Puerto Rico right now. So we're seeing this across the islands in the Caribbean. And this is kind of where we are trying to, actually, we already have a few projects down here where we're doing microgrids. This is where it's making sense for a solution for this area. So 2G as a company's focus on the engine and cogeneration. Out here, we're starting to incorporate microgrid. So incorporating a solution with battery and microgrid controllers as part of the solution to simplify the development on microgrids. So it's just pretty much having the best of both worlds, resiliency and cost effectiveness of traditional generation, plus the efficiencies of cogeneration. And then obviously we got a lot of sun down here, so it makes sense to have some solar and batteries as well to ride through. Actually, they didn't cover it here in some of the slides, but that improves the power quality when you're connected with our system. We already seen some of that in our sites. It's the power quality on the islands in some areas more than others. It's not the greatest, and that as consumers we feel it with our fridge goes down or some of our equipment gets damaged. In the industry, it can mean thousands to, in some pharmaceutical cases, maybe even millions of dollars if they lose conditions on clean rooms and they have to dispose of product plus the operation stuff. It's yeah, and having those systems online can help you improve the power quality. And if in a well-designed, resilient system, it can even help you ride through some of the events of the swells and dips on the power on the grid itself. Actually, I'll briefly touch over this because I like it because a lot of people might think it doesn't make a whole lot of sense. Like, oh wait, making hydrogen from green energy to there's some arguments. Just Ireland is already at this point where they have excess renewable, and they are to the point where they're going to start producing hydrogen to bring into the market. And so this is in fact an alternative. And obviously we do have hydrogen products, so we obviously love to see if this path towards that renewable transition happens to where the point where we can run our hydrogen products out here in the island with this type of renewable process. And here I'll go over some of our installations briefly. So this is for pharmaceutical. We have this 3.3 megawatts where we are supplying to this site with steam. They actually have a configuration of 2 engines to 1 steam generator and then a 1-to-1. For this specific site, we supplied the equipment and the commissioning of the equipment, and obviously supported the design on the interconnection for the interfaces with the local engineering firms. And in operation for about 2 years now, a year and a half, I believe. Actually, I'll go into the third one to go into a little bit more of detail, but just another installation we have. This is in Santa Cruz. This is the picture we got right now. This is actually leaving production in about a month and a half to head to Santa Cruz. It's 2 engines, different size units. So this is 1 megawatt, 1 500 into steam generation. This is some of the design. Obviously, this helps customer visualize their installation and request some changes. And the one I want to spend some more time, I'll try to move quite quickly through this one. It's another pharmaceutical system. The red dots in there, those are the on-site work that had to do for piping configuration. Everything else was pre-assembled, pre-tested on Germany, which obviously helps with the process of the installation, the commissioning, and it makes the on-site commissioning so much easier. And this site's been running also for a year and a half, I think, at this point, closer to just a year. And this site we're doing cogeneration with a Sturgeon chiller. This is a 1.4 megawatts of production with I think about 320 refrigerated tons of chilled water at 42 Fahrenheit. And should they mention, but both this and the other units are on LNG for fuel. Yeah, and just to close on the presentation and pass it on to Will, I just wanted to like live with some of the challenges and considerations that I like taking, just showing this, because this is some of the things that we run into down here. It's like the technical challenge. It's like, so we made the interface simple enough, like integrating with existing infrastructure. Um, sometimes you don't really know what you're going to run into. So that sometimes it's one of those hurdles, like the more you can understand what you're connecting to thermally, electrically, it definitely helps simplify the integration process. And the what I call complex multi-boundary interfaces, which is we typically have a customer and that customer has a end user. And that lapse of who's connecting to which point and who's doing what. So we call it basically the responsibility for each aspect of it. It's where we sometimes see gaps when it comes to the installation and integration of the systems. And financially, at least for the Caribbean, like we do have some funding available for and some projects as far as like ITC and some other funding for like high energy efficiency systems. But for cogeneration with propane or natural gas only, it's not as much funding as it could be down here to help move it along, and the return of investment and resiliency, because return of investment for the systems comes in obviously with the cost that there is, but resiliency costs additionally. Meaning having, we call in the industry N+1, so another engine on the configuration to ensure one engine goes down, you can keep running. Design considerations for island mode, which means if the grid goes, you can't keep running. That has an additional cost. And sometimes having that resiliency capture as a value, it's hard to get across to the customers. And this is more of a Puerto Rico thing, but the permitting process, it has improved, I'll say, at least on my time in the industry. It has still ways to go, but that's where some of the challenges that we're seeing, and I'll close with this slide and then hand it off to Will. I like showing this to people because I asked ChatGPT, hey, help me design a microgrid. And this is what it came with. So we're not at that point where we can just hand this off and tell our future AI overlords do it. We need people to have the knowledge and figure out how to make sense out of all this. So with that, thank you for your time, and I'll hand it off to Will.
I'm excited to see that ChatGPT at least recognizes the presence that CHP is like a thing. I feel like that's progress. Okay, can y'all see my presentation?
Yes, looks good. Thank you.
Okay, wonderful. Okay, so I work for Charlotte Water, Charlotte, North Carolina, and my name is Will. So I'm just going to talk about like our very specific, just singular installation in Charlotte, North Carolina. So Charlotte Water, as was mentioned earlier, is sort of one of the largest utilities in the Carolinas. You know, as it goes, large utilities always argue over who's the biggest. Charlotte is one of the largest metro areas in the Carolinas, and especially it goes across the border slightly as well. So that's our argument as to why we're bigger. More than 1 million people. We do water and wastewater services. Roughly, I think it's 110 million gallons of clean water that we send to homes every day, and then we recollect about 100 million gallons a day to treat and put back into local creeks. And then most recently, stormwater. The city stormwater department has also sort of come under our envelope. So we're a holistic water organization now. And really a department of the city of Charlotte writ large, but we are an enterprise fund, so no tax base. All the money that comes in from the sale of water and the sale of wastewater treatment is what supports the organization, even though it is a subsection of the city itself. So just a little general about Charlotte Water. And then my name is Will. I've been doing project management for about 14 years now. Got my PE in environmental, and then other various degrees. And then in addition to project management, I sort of fell into doing this role of managing state revolving fund money. So I've helped sort of manage and fund 6 of our projects for more than $110 million in low and no interest loans that will last. They started a while back, but probably another 15 years until we've finished paying off all those loans for the projects that are already complete. All the projects are done now. We're just managing the back end. And then my last sort of hat that I wear is the generic sustainability guy at Charlotte Water. So whenever the word solar or EV or CHP or any kind of buzzword gets mentioned, then my name comes into the conversation, and they say, let's see what we've done in the past, what we can do in the future, and how we can do it with limited resources. Right? Funding, of course, is always the problem. So we're going to specifically talk about our CHP, our combined heat and power facility, and like any successful government project, there's extensive studying that happens beforehand. And so our first study was done by the NC State Solar Center back in the day, 2009. Isaac actually helped with that. Long time ago was the first initial preliminary study that said, hey, you have a treatment plant, you make a bunch of biogas, you should look at utilizing that biogas. So on the heels of that study, we paid a consultant to further look at our gas quantities and our options. There was a lot of overlap, but it came to a lot of the same conclusions. Internal combustion engine was going to be the best possible scenario. Not quite enough gas for a gas turbine, and then not quite clean enough fuel to do something fun like a fuel cell. So internal combustion CHP was the sort of chosen technology. Abundant Power, another consultant, came in and helped us do sort of a financial model, looking at doing just with our regular biogas, but maybe also with food waste receiving or something like that. And then there was still more studying to be done. So I eventually became an employee and just spent a ton of time just making phone calls around the country to current CHP owners at the time, just to get their lessons learned and their experiences to try to figure out how to implement our own project. And then we took some trips to Virginia and North Carolina, other sites as well, to see what they were doing and how they were doing it. So that was all before the project even really got started. The project had been sort of part of the conversation for a long time, but with water and wastewater capital projects lists, and especially with a lot of projects that were compliance required, right? So making clean water as a part of compliance is our core business. This project never really made the cut. We were always project 101 on a list of 100 projects that were going to get done. So continue not to get funded in the list. Then right around 2015, my boss at the time said, hey, look into the state revolving fund, see what that is, see if we can get money for that. So went ahead and did an application in 2015, did not get funded, but did learn a lot about the SRF program. And then in 2016, we were able to get funding and we were able to go ahead and purchase a CHP engine. And so that all seemed sort of straightforward. And even then that wasn't straightforward. I mean, there was these 2 big things had to line up for us to really successfully implement our project. And so one was the SRF loan. We got a 20-year loan at 0%. It was considered a green project. So because we were generating energy, we got that 0% loan. They don't have that anymore. That was a special thing back then that has since changed. But even that wasn't enough. At the same time that sort of came to fruition, I got a call from a vendor and they said, hey, we had 4 1-megawatt engines that were part of the way through procurement. Like they were already producing the engines and the orders got canceled. So they said, hey, if you're willing to take one of these engines, we'll give you a discount. You don't get to choose your features. It's all been set. And so we sort of agreed, and we got a pretty steep discount on a single 1-megawatt engine. Our initial plans were 2 megawatts of capacity, but again, with funding being a problem, we went ahead and just jumped to the chance to get 1, and had plans to build the second one later. So we did successfully start up in March 2017. And today we have more than 40,000 run hours on our engines. We pretty much run them as much as they can round the clock. The engine we got, a 1 megawatt Jenbacher J320, is designed to run 24/7. We actually initially ran it at 100% capacity. We have scaled back just a little bit, run at about 95% capacity, just because we have a few less problems at just a slightly derated setting. This is I remember this day very specifically. So we had the crane coming. I had to get a crane operator to come, and they dual lifted this 64,000 pound containerized 1 megawatt generator. The trailer was too long to make any of the turns in our treatment plant, so we had to move a bunch of stop signs and other obstacles to get it into location. And then we offloaded it on this very same day. The county was putting in a greenway bridge at our other treatment plant, so there was also a bunch of cranes over there trying to figure out how to put a 100-foot bridge across this creek when they couldn't reach from either side. So there was a bunch of crane activity happening on this very same day. I was driving back and forth, but it was pretty exciting. At this point, we knew the product was going forward, right? We had bought the engine and it showed up. There was sort of no going back, right? I had made it so that my organization couldn't change its mind. Here's what it looked like before we had installed it. It's a 1 megawatt facility. This is the rest of our treatment plants around it, of course. It's on about a third of an acre, which I love to talk about the size of what it takes to make 1 megawatt of renewable energy. You need a third of an acre. If you want to make 1 megawatt of renewable energy via solar, you need 10 to 15 acres of property. And you, of course, don't get it at night, and you don't get it when the sun's not out. Whereas this CHP runs around the clock, rain, shine, night, day, doesn't matter. This is the final fully completed package. We do have heat recovery, so some of the pipe in the right side of the picture and in the background, that's part of our heat recovery loop, and we take that heated water and run it to the digester. So in the very background is the digesters. That's where we're actually making our gas, and our digesters need to be sort of human stomach temperature, right? They're giant human stomachs. They need to be human stomach temperature. So we heat them, they make more gas, use that gas to then make more water to heat that water to make. So we have a nice little feedback loop there where the gas production is based on our temperature production, which is based on our gas production. So nice little virtuous loop there. We also do gas scrubbing. So in the background as well, you see some siloxane removal there. We have some boosters behind the unit you can't see. But for the most part, everything came inside the container. We took it out, mounted it on top, and that's the facility. Lots of heat exchanging going on there. Big radiator on top. The far left is the air intake box, giant filter box, basically. And yeah, really cool inside there. Really cool to go inside there when it's running. It's a 20-cylinder engine. Some of the temperatures on the heads get to like 600 degrees C. Whenever I don't insulate the engine correctly, you can kind of see little pockets of bright glowing steel through some of the openings. It's really exciting and neat. And then of course that's just a big giant muffler on top there. It's pretty quiet. If you stand on the right side of there, that's sort of where the hot air comes out. It's the best place to stand on a cold winter day because you can stand outside and it's nice and warm. And that's our 1 megawatt system. We sell all to the grid. 100% of the energy goes back onto the grid locally. So just real quick, talking about some of our O&M issues and lessons learned. The engine did sit around for a little bit before we were able to install it. We kind of put the cart before the horse. I made sure we bought the engine, and then we decided to go ahead and do design and construction. So there was some downtime there, and we did some PM work to rotate the engine while it was sitting around to make sure the bearings didn't get flat spots. But even so, even with the PM work we were doing on the non-running engine, we still ended up having a lot of leaks and loose hoses and some other premature sensor failures just because the engine sat around for about a year before we were able to turn it on. So of course I wouldn't recommend doing that. Obviously coordinating install at the same time as when it shows up is much better, but it was just sort of the unfortunate circumstances that we were in. We have a service contract with the engine. Our service provider got bought and sold. So Jenbacher was a company owned by, I think eventually they got bought by GE. And then our local distributor was Nixon Energy, and the Nixon Energy sold off that unit to a company called Ineo. So we've had some changeover in the contract and some changeover in the labor of who's in charge of it. That can be tricky. And then, whenever we have parts that we take off the engine, I always try to hoard them because it's always good to have. Even if they're used spare parts, it's better than no spare parts. So I'm a big engine parts hoarder as well. I'd suggest doing that. And then the last thing we sort of learned was that the gasket was a different package. So Adil talked about that earlier. You know, the gasket oftentimes with the gas production may be different from the actual CHP system. And so figuring out how to get those systems to line up is tricky. We wanted to have a service contract for our gasket provider, and we called them up, and they said, "Oh, we don't do that. Like, we just don't have that. Like, we can send you the sales guy, and he can tell you how to do stuff." And we didn't want that either, so we kind of had to do a lot of that in-house, even though we didn't necessarily want to. Which meant in many cases it was me doing that in-house. So changing out siloxane, once a quarter, come away looking like a coal miner. Activated carbon can be a little bit dirty at times, but it's just you gotta do what you gotta do, right? So this is my last slide, I believe. So some of our big lessons learned, when you're implementing CHP, a wastewater treatment plant, a wastewater treatment plant is designed to make clean water, not necessarily the core business skills that everyone else is trying to do there. So just sort of keeping that in mind that, if wastewater pumps break, then those become priority over whether or not the CHP is running. So the CHP was always sort of the last priority, which meant that oftentimes it was myself working on them as a project manager because all the treatment plant people were doing treatment plant stuff. So that's just sort of a tricky little issue you may have to navigate if you're implementing at a treatment plant. We had some sort of realizations, some expectations for reality kind of situations where we're balancing, do we really need to have this? And, or is it sort of a nice to have? And what does success look like? And, what were the costs, what we thought the costs were going to be, and what the costs actually were? And, how does that change your business case, right? Trying to be super conservative, and it may look like it financially won't pan out at all. But you want to get the project to go forward, knowing that there's going to be some difference between what you're hoping for and what actually happens on the how much money you may make back, or as you mentioned earlier, like how you're costing out the value of resiliency, right? The value of being able to produce on-site energy. Uptime was also an interesting discovery. I mean, the engine we have can be very finicky, which was nice. Like, it wasn't ever going to break itself, but also it was gonna shut itself down if things were just even the slightly headed in the wrong direction. So just being present, I feel like myself and the engine eventually formed a little bit of an emotional bond, right? And so sometimes just having to be around it and just speak nice words to it and be kind, and that oftentimes would sort of alleviate problems or make things go away until we figure out what was going wrong. But you have to be aware and looking at it every day and checking it all the time. They're not set it and forget it by any means. The last thing, of course, is to figure out, you're wanting to buy a CHP or own a CHP system. The real question is why. Like, is it important for you to really own that system, or just to have access to that system? So the ownership question really is important. What is the why for doing the CHP? So resiliency is a very frequent, very common reason to do CHP. At our treatment plant, we already had backup diesel generators, so resiliency wasn't really an issue. So we didn't end up having island mode on our facility. So we export all the power directly to the grid. If the grid is down, we can't export. And if the grid is down, we're already on island mode with our diesel generators that were required by regulation. So resiliency wasn't a big issue, or wasn't a big part of why we were putting in our facility. Obviously, it is a huge value add for a lot of other facilities, especially, literally island mode on islands makes sense, right? So sustainability was a little bit more of a driver. So just using our biogas. So if that's part of it, you're making your own gas and you want to try and use it, that might be your driver. Then the question is, well, how much engine do you put in, right? Because if you want to use all the gas, then you're going to have more engine than you need to deal with fluctuations and to deal with peak. If your goal is to have your engine run all the time, then you're going to have less engine because your gas is going to have a low point at some point, right? So trying to figure out which one of those goals you want to sort of go after if sustainability is your motive. And then obviously money, Are you trying to make this financially pay out because you're doing peak shaving or because you're doing net metering or internal generation? You know, what if money is the driver, then those are the questions you need to sort of be asking. How are we monetizing it, or what is the monetary value? And then that leads to the question of, well, should we make more gas, right? Because making more gas is always another interesting proposition. Can we do food waste receiving? What else can we put in the digester to make more gas, right? We have gas makers, and so how do we make them make more gas? That's always a secondary conversation after you've done CHP or gas utilization. And that's all I have for my portion of this webinar. That's my contact there. So screen cap that real fast. I am going to hand it back over.
Great, thanks
Sure.
so much, Will. When we work with people, we always ask them, you know, do you have a champion for this project? And it sounds like you're definitely that person to really make that project move through and continuously work with it and make sure it's working. So that's great. It's great to hear your story. So I'm going to, can you all see my screen? Great. So I'm going to jump in here and switch gears and kind of talk about NC State's Centennial Campus and the onsite energy projects that have been added here on our campus. Again, our program, we work out of NC State University. So I've just written a case study on this, and all this information is fresh in my brain. So I'm going to share some of that with you today. For context, I'll start. The Centennial Campus is a newer part of campus, and it houses research facilities, the College of Engineering, and more than 70 company partners. So it's really a space for, you know, innovation. And they've implemented a 157 kilowatt DC solar PV array on top of Fitzwillard Hall. We also have a combined heat and power system with a capacity of 6.5 megawatts. And we've also got a battery storage system that can provide 250 kilowatts of power and store 430 kilowatt hours of electricity with a lithium ion battery. And lastly, we have a chilled water thermal energy storage tank of 3.3 million gallons, and it's filled up to 3 million gallons. So on the right, you can see a picture of the Centennial Campus utility plant, and the chilled water thermal energy storage tank is over here to the right, which is 85 feet tall, so it's quite large. And down here, you can see a picture of a tour being given of the Fitzwillard Hall PV system on top of the roof there. So the benefits that have come from these systems on this part of the campus, the CHP system has reduced the campus energy by about 5 to 6%, and the greenhouse gas emissions have been reduced from the baseline by about 4%. There is a CHP system also on the main campus. It's called the Cates facility, which you can see kind of referenced in this quote at the bottom. And together, those have reduced the greenhouse gas emissions by 12%. So this system is a little smaller, but still contributes to that for the campus. And combined for all of these four systems, the university saves about $1.26 million annually. And another great thing about campus then is that it is a microgrid with the capability to island, like you know, Will was just talking about, and can still serve the university and its private tenant facilities in the event of a grid outage. So I have been speaking to some key people at the university that were involved in some of these projects and been able to compile a list of the lessons that have been learned from these projects. So I'm going to share those with you. And for the CHP and thermal energy storage tank, there were some important considerations dealing with the utility rates. So here there is a time of use rate structure for the chilled water storage tank, and a control strategy is necessary to come up with the most cost-efficient times to charge and discharge the water in the tank. Same with the steam turbine generator. And in the CHP system, it can also be dispatched based on those time of use rates. And it's important to have a strategy to find the best times, again, to dispatch based on those predicted energy uses. And you should be prepared that those rates might change, which happened to us, and immediately begin discussions on how to plan and modify your charging and discharging strategies and controls. And up here on the right, you can see a picture of the Centennial campus, and the utility plant and the water storage tank is here in the front. So this is kind of a nice overview picture of Centennial. Next thing is to, understand your load profile. For the chilled water storage specifically, it's important to understand the campus chilled water load profile as well as the electrical demands, before you embark on this type of project. And from that information, you can work closely with your controls contractor or engineer to develop a charge and discharge strategy that will allow you to maximize your electrical energy savings. It's also important when you're implementing a CHP strategy to understand how any unplanned trips of that equipment is going to impact your overall savings for either the month or the year. And you can work closely with the engine manufacturers to ensure proper parts are on hand to maximize the equipment's uptime. And just like Will said, even if you're holding on to a used spare part, it's better than having no spare part. So it's a really key thing to have things on hand, so you're not just waiting around with the system down and losing all of your savings. You at least have things on hand you can try to implement immediately to get that equipment up and running again. And over here on the right, this is a top view of the chilled water storage tank, and there is now a logo of our university on the top, so that if you fly into Raleigh-Durham Airport, you might be able to see it. All right, so as far as training goes, be prepared to provide an extensive amount of training for all of your operations personnel, especially if this equipment is new to campus or a facility. The equipment and its operations can be overwhelming, and we found that including our personnel as much as possible during the startup and commissioning phases was really helpful to help the personnel be more effective at operating and understanding how to react to unforeseen events. And it's also important to make room in the budget for operations and maintenance. So each machine in the utility plant has a large monthly cost to receive preventative maintenance, and engine swaps need to be swapped out engines need to be swapped every 5 years. And lastly, for this, for the utility plant, the collaboration is important with your contractors. It's critical for success in the design phase, construction, and the controls phase. So for the utility plant, the CHP, and the chilled water storage tank, these lessons learned were provided to me by Bill Farrell and Steve Lysenko, and they were the plant manager and plant engineer, respectively, during the time that the CHP and the chilled water storage tank were added. And Steve is now on our team. He used to be a plant engineer, so he's been a great resource for us to connect and understand all this information and now relay it to other people to learn from. And lastly, I'm going to quickly touch on some lessons learned about the solar project on top of Fitzwillard Hall. I learned these lessons learned from Eric Weiss. He's a university preventative maintenance engineer who was involved in this project. So I was able to speak with him and get these lessons learned from him. So he said for the wiring, so if you have a roof mounted solar PV, make sure you have a plan for how the wires are physically going to be routed. Are the wires going to run through the racking, or will they run in a conduit around the racking? So think about those things and watch for any abrasion concerns with the wires, for the weather conditions over time. thinking about, are the wires going to rub on the racking as the wind moves them over time? And also to ensure that the ties used to kind of tidy up the wiring are actually rated for outdoor weather. Plastic zip ties might not hold up as well as you think they might. And he also mentioned, to get operation and maintenance personnel for the actual building involved in the process as early as you can, because they'll be able to tell you how much space they're going to need around the existing equipment on top of the building, like the HVAC system, to do their typical maintenance, or if those parts are going to need some sort of part swap, how much space are they going to need around that? If the person designing the system, they may not have that information without their input. So, and you might have to go back and change your design if you get that information after the fact. So, it's important to think about that up front and get them involved. And lastly, for installation, it's important to set those expectations with the installer company before the project begins, and have a contract and a meeting up front about those standards and specific specifications of the job. Because the university, this is on a state-owned building, some of the standards were a little more rigorous than PV installers are typically used to. So, just being able to be upfront and make sure everybody's on the same page about what's required for the job, and also to have somebody, either internal or third party, completing that quality control along the way. Yeah, so these were, this is just an overview of some of the lessons learned for the projects that we have on NC State's campus. And with that, I will hand it over to Isaac to moderate our discussion about our onsite energy deployment.
Thank you, Anna. Those are some really good lessons learned, which I do appreciate. As a former consulting specifying engineer, there's 100 things you need to be thinking about, and it's that 101st thing that's going to get you in the end. We're going to have a discussion of on-site energy deployment best practices next. But Anna, we could just kind of run through some of the subsequent slides here. And I did want to say, please enter your questions in the Q&A. We really want to hear from you as to things that you're wondering as you're considering on-site energy, not just CHP, but also solar PV, battery storage, chilled water storage, etc. This slide here first shows how to work with your on-site energy taps. If you could go back to that, please.
Yep.
First step is to contact us or your regional tap, depending on where you are. We'll work with you to discuss your site characteristics, your goals and objectives. We really want to understand your goals. We might even talk about looking at a number of facilities across your portfolio and evaluate them to figure out where the best opportunities are. We will collect a lot of site data so we understand the things like the existing conditions, how much you're spending on energy, where the opportunities are for on-site energy, depending on or based on how each different technology can support your needs. We'll conduct analysis of on-site energy for your site. That would include the sizing, cost, budget cost estimation, as well as payback, including any applicable incentives or tax credits for those. And then we'll review the results with you and help you come up with a strategy to implement on-site energy. One of the grant programs available right now on the next slide are the IAC implementation grants. These were put into place under the bipartisan infrastructure law. There is available funding of up to $300,000 per quarter for eligible entities. Primarily, eligible entities are medium and small size manufacturing firms, as well as water and wastewater treatment facilities. And one of the ways that you can qualify for this grant is to get a recommendation from either a DOE Industrial Assessment Center, DOE Combined Heat and Power, or On-Site Energy Technical Assistance Partnership, or a third-party assessor that's been deemed equivalent to the previous two by DOE. So working with us will help you qualify for this $300,000 grant per quarter. Next slide shows, I think, some further information on the implementation grant, just really summarizing the eligibility requirements for the grant. And then on the next slide just shows some of the process for that. I want to quickly move into our discussion here. So Anna, if you could stop sharing just for now. I see all of you have your cameras on. Let's see. If you want to switch over to gallery view, we're going to have just a little discussion. You guys, Adele and Will shared a lot of really great insights on developing CHP facilities. I was wondering if either of you are looking at other on-site energy technologies or have implemented other on-site energy technologies. Let's say for Adele, have you looked at or are integrating CHP with solar storage? And Will, are you looking at solar for other Charlotte water installations?
Yes, I'll jump on that. The answer is yes. Like, I mean, on how the market, and it just makes sense specifically for the Caribbean. Currently, one of the slides I showed for the San Croix project, Santa Cruz, that is, we're working with a partner, but it's 2 megawatts of solar, to I think this battery storage system. There's a backup diesel, there's propane, and there's 2 natural gas engines that we're providing, and we're helping with the engineer of record on the putting all of that together. It's going to be a very, very interesting microgrid. Additionally, I know if we have a project in California, exactly where we're working with a partner. We have our cogeneration system. They have biogas, and they're using that electricity for electrolysis process to produce hydrogen. So another, that's actually very, very, very interesting project that we had in California. And as a solution, like internally, like we're looking, well, like I mentioned, we have heat pumps. Like, so now it's just cogeneration and adding heat pumps into that aspect. And specifically for the Caribbean, we're in the process of, aside from our cogeneration, integrating battery storage and the microgrid controller. So it's pretty much just a matter of what's the other distributed energy resources. We'll bring it in and make part of the microgrid. So just kind of provide that one solution. And so, yes.
Yeah, I appreciate the holistic nature of what you guys are doing. With the heat pumps, I'm just curious, are you using that to increase the temperature of the output from the CHP, or how are you using the heat pumps in conjunction with the CHP?
Just to provide heat and cold to the buildings itself in Europe. It's just like providing from the electricity and just increasing the overall efficiency of the whole system. So it's less in Europe specifically. There's a whole push for electrification, and the government it's making a huge push to move in that direction. We do have we do expect the same to be happening in the U.S. In the coming years.
Great. Will?
In terms of adding solar, we just finished up one of our large field operations zones, rebuild, and we added 50 kW of just ground mount solar there. We've already got a backup generator there just to run the office complex, but we went ahead and added solar. The city of Charlotte has a new sustainable energy plan that they're trying to meet across the board. So that was partially to meet the requirements for that facility, just adding the 50 kW of ground mount solar. Other than that, funding is just always a huge challenge for public utilities. So trying to figure out, well, how do we implement solar without having to put any money in, right? And so we do have land, we have lots of available space. We were able to manage to create a partnership with a local utility who was already doing a large solar for their own purposes, a large co-op utility. And so they're going to go ahead and their development partner is going to put in 1 megawatt of solar on some of our property. And that will all go straight to the grid. So we won't necessarily benefit too much, other than the fact that we are sort of helping to drive down, the carbon intensiveness of the local area grid by hosting a solar facility. So it will be 10 to 15 acres of solar, which we're pretty excited about. And it's sort of a feather in the cap project as opposed to a capital intensive project. It's gonna be cool. It's gonna be neat. but they won't give me money to spend on anything. So I had to figure out a way around that. And that's how we figured out a way around that.
Well, that's good to hear about the 1 megawatt solar project you're doing. I know a lot of the focus has been on large scale projects, but I think a small scale project can really have a important local impact. Continuing on our discussion of design decisions and impacts. So how does I guess your sizing get determined? What drives the sizing for your projects there? Is it primarily electric load or thermal load or combination? How do you go about that?
I mean, for us, it's gas availability, right? So our projects are all biogas driven, or our one product is biogas driven, and how much biogas we have available. So that's what it had determined the sizing. We didn't want to get into the concept of buying natural gas to make on-site energy. That wasn't part of the driver of our project. So that's definitely more of a DL question, I believe.
Yeah, I mean, from our side, typically, like it's the electricity. Like we do look at the electric profile, and that's the major driver to most for projects. Does it make sense as far as like how much generation you got, your load profile, and then making that financial reviews for, it got to make sense for everybody at the end of the day. So that's the major one. Like a secondary will be like, as Will mentioned, like you got to buy product, and this is our limitation, so that they'll come out with this is what we can get.
Great. And the byproduct you're talking about is thermal. It's interesting. We're working with a site in Puerto Rico that's all mostly electric, and they're actually looking at CHP, but we'll be looking to maximize the use of the thermal, really just to improve the operation of the system, the efficiency of it. Are there, for the biogas system, with unavailability sometimes of biogas or with, propane or natural gas system, you might have curtailments or unavailability of fuel there. Did you look at or evaluate implementing a dual fuel system to mitigate that risk?
I mean, so in the end, we ended up doing a sell-all agreement with the utility. So 100% of the power we produce goes to the grid. And so the idea of buying fuel, even just partially buying fuel to then provide renewable energy to the grid didn't make sense. And I mean,
Okay.
The slide earlier showing the power costs for Puerto Rico, I mean, I know that's supposed to be a doom and gloom slide, but man, if I had those kind of things to put into my payback analysis, I'd be doing CHP everywhere, because I mean, the Southeast has just incredibly cheap power. So even with moderately cheap gas, it's probably not financially viable to be making power from purchased natural gas. So long answer, short answer, no, we did not look at dual fuel for doing CHP.
Okay.
Yeah, I can chime in for NC State side of things. If the campus is curtailed, which usually happens in the winter, we do have 40,000 gallon tanks of #2 fuel oil for backup to use instead.
Oh, great. Thank you. I'm going to move on to funding alternatives. We actually have a question about funding alternatives, about where you can review the qualifications for the federal funding. And I think it's the grant program that we just showed, the Energy Works. Well, Energy Works is the organization that administers the IAC grant program. And if you could provide a link in the chat, that would be great. We'll have that recording online probably next week, and we'll send that out to everybody. But I'll put a link in the chat here right now for everyone. This is the DOE's Better Building Solution Center, where you can see not just past TAP on-site energy tap events, but future on-site energy taps events. I do have a question about the federal energy investment tax credit, for you, Adele. So you said that is something that plays into the project economics, and that I think is through tax equity investors. Is that right?
Correct.
Okay, but now going forward, as has, with the changes, there's now this direct pay incentive for nonprofits. That would apply to Charlotte Water and maybe to Puerto Rico, where there isn't like really tax on certain things. Has that driven Charlotte Water to look at additional on-site energy projects, Will? The direct pay incentive?
As far as I know, we're not for further generation. The the financial divide between successful payback and cost is still, there's still some gap there.
Okay.
And then again, we're still coming up, infrastructure renewal in general is a problem across the country, right? So our CIP hasn't gotten any looser in terms of prioritization. So on-site generation is still, or on-site renewables is still a fairly low priority thing. Just because of the nature of our business, we're clean water is the nature of our business, right? So
Absolutely.
that being said, I think we are looking at that credit for EV and EV related infrastructure. I think the city is doing some look at that credit citywide for EV related stuff.
Okay. Ideal. Are developers or owners in Puerto Rico able to benefit from the different rules of the tax credit?
As I understand, yes, but the focus has so far on development has been on the tax actual credit itself. Not that hasn't been. I need to keep my ear a little bit closer to the ground. But as far as for the direct pay, it probably still trickling in through some of how developers are going to move in to help some nonprofits down here. But
Gotcha. Well, the IRS is, just recently released rules this summer, and there are more rules to come, especially as we go into next year. A little bit about commissioning and startup. Did your projects or do your projects use third-party commissioning agents, or are they owner commissioned, or how does that work for you?
I guess I can go first for our size 2G. So typically for our system, obviously we provide the system, we provide the commissioning. For some of our auxiliary equipment, we do work with our partners, and we sometimes even commission their systems. Surgeon chillers, it's the only one where we left for the OEM, but the rest, pretty much everything at the end goes through us. So we're involved in the whole commissioning process, except for the utility interconnection. Obviously, that's third-party consultants and everything medium voltage and above. Then it goes a little bit beyond our scope.
Yeah, for our facility, the distributor did the commissioning as well, and they were also going to be doing the maintenance. So the party that we had contracted maintenance with was the party that did the commissioning for us. So I guess it was, I mean, it wasn't GE, it wasn't Yenbacher, it was, so I guess you could say it was a third party, but it also was the party that we were going to be in relationship with for maintenance. So that made the most sense.
That makes sense. Anna, you have anything to add on commissioning, or?
Yeah, just as a state entity, we were required by law to hire a third party to do commissioning, but yep, that's all I have on that.
Okay, great. Well, commissioning is an important process where you establish your requirements and make sure that they're met throughout the whole process. So good to hear that everyone's doing that. I'm going to really kind of ask one more question and give you guys a chance to add anything you'd like to say. Long-term ownership. What advice would you give to plant managers to ensure that their on-site energy project is as trouble-free as possible over its life cycle?
I mean, I would assume that yes, the ideal world is trouble-free, but don't think that that's going to be reality at all. So you should assume it's going to be troublesome. You should have one person who's going to be in charge of dealing with the trouble, right? I think just sort of going into it eyes wide open on that it needs to be someone's baby, right? And you got to take care of the baby. So, and it can't be the stepchild, right? It's got to be a priority. Because if it becomes an accessory or nice to have, then it just won't get tended to, and then the less you tend to it, the worse it will get. So you just gotta keep it forefront of your thoughts and your actions.
100% agree with Will. Obviously, I do have a bit of a bias since we do provide the service and operations and all the additional just everything required. But this is as far as like what we have seen. Like when we do take a lot of ownership on our product. It's our product, our sticker. So we do go in there and it's our baby. And when we're doing the operations, corrective, preventive, that's where that over 96% availability comes into play. We do have customers that do take to heart their systems, and they take the training, they send their personnel, they keep them educated, they keep them engaged, and they can get those numbers. But the second that they just step away and stop caring, that you can see that availability just go down. It's just the reality of it.
Gotcha. Anna, did you
Yeah,
have?
thoughts and prayers don't keep CHP systems running, right? It's I mean, it is weird. Like literally just like being more present seems to make everything run better. You do less work the more present you are, even though you're available to do more. So, but it's almost like just like again, just being available to do more means you won't have to. It's a weird backwards thing, but that seems to be the reality. The gremlins all stay away whenever you're there.
They keep out. The more you're there with a shirt rolled up, more grease, the more oil you have in you, the more like the more the engine stays on. That's
Gotcha. I have a couple other questions came in the chat or Q&A here. One is for rural governments. Does USDA have specific grants specific to these types of energy projects? As far as I'm aware, probably the Rural Utility Service is one place to look at for possible grants or maybe loan programs. I honestly am not entirely sure about governments. We have a program actually that we're part of at NC State, the REAP program, the Rural Energy for America program, where they do provide grants for small businesses, rural small businesses, and agricultural producers. If you reach out to us, we'd be happy to look into this question for you a little bit further. And then one more question. This is for Will. You said that it's a sell-all agreement with Duke Energy that you have. Does the city of Charlotte take credit for the renewable energy, or does that go to Duke Energy? And
Yeah, so we're selling all the power, but we carved out the RECs, the renewable
Okay.
energy credits. So we carved those out. We do own them and we keep them, and that's going towards that goal. That's partly how we're meeting that goal is through RECs. Correct.
Awesome. Thank you for
I've
that.
become a REC manager. That's the fifth or sixth thing that I do as well as I manage our REC program.
Great. So Ed, I just want to, thank you both, Will, Adiel, and Anna, of course, for producing this, really valuable information that you all have shared here with everybody. We appreciate everyone attending the webinars that we've held this summer here. I want to give Adiel and Will a chance to add any last thoughts before we wrap up.
I guess I'll go first, and this is just like to me, one of the key success for projects that go well, planning. I think that the planning and making sure to invest the proper time for the design considerations of the installation, like even planning for maintenance, like planning how you're gonna manage to take care of some of the equipment, the location and access to some. These are things that typically are left behind with the numbers and the return of investments. But that's, I guess, the one thing to left off will be, yeah, just to make sure that for a best ending comes from a great takeoff, and a great takeoff comes from investing time in planning and design considerations.
Yeah. I think at this point, there's no excuse not to do CHP if you have a fuel source. So if you're a wastewater treatment plant, you're doing anaerobic digestion, you've already made that investment and you're making gas, there's no excuse why you shouldn't be doing gas utilization at scale, like 100% gas utilization if possible. We know how to do that with CHP. there are other alternatives, but there's plenty of private entities that would love to invest in that if you're going to give them some benefit, or if you have the capital costs, you should do it and get the payback. I mean, there's a lot of anaerobic digesters out there that are making gas that we are flaring in this country, and at this point in time, there's no real excuse for that anymore. We know how to do it, we know how to procure it, we know how to install it, we know how to run it. And you saw 2G, 50 kW, I think was the smallest one. I mean, that's tiny. And then what, 6.5 megs, that's huge. So like the full range of product exists. And there's investors that would love to build that. So public utilities should all be doing it. There's no excuse anymore. That's my my angry words to those out there who aren't doing it yet.
Passionate, very good. So I just want to summarize, and I agree with both what you said, Will and Adiel. For us, it is implementing on-site energy. It's really a complex process. There's multiple steps and decision points, and it really requires critical thinking. That's what we're here to do, to help you with. And we really want you to ultimately have a successful outcome, whether it's in terms of cost savings, carbon reduction, resilience, and just having a shared accomplishment and owning a really great on-site energy system that everyone can be proud of. With that, I guess, Anna, you want to show us the last slide and wrap up for us, please?
Sure. I just want to thank again all of you for coming to our series. Hopefully you've learned something, and feel free to reach out to us if you need any help. It is a free assessment that we can do for you to see if you could implement any of these technologies. And just thank you again, Adiel, and thank you, Will, for bringing your real world knowledge here to our webinar series, and really helping people understand what it's going to take to implement these projects. So we really appreciate it. And if any of you need to contact us at our TAP for the Southeast, Isaac and Arts and Dr. Pedro Quintero's information is here on the slide. But thank you. I know we went a little over time, but thank you all for your attention. We really appreciate it. Have a great one.